Imagine this. A nuclear bomb strapped to a rocket launched into the silent darkness of space. Detonation countdown begins. What happens next? Would it be the blinding flash familiar from apocalyptic movies, a mushroom cloud billowing against the backdrop of the Earth? The answer, like space itself, is both simpler and stranger than you might think. Out there, in the vacuum of space, a nuclear explosion would be a very different beast. Intrigued? Let's delve into the science behind this cosmic light show. The moment a nuclear bomb detonates in space, there's a burst of blinding light and intense heat. This initial flash is incredibly bright, almost like a second sun appearing out of nowhere, illuminating the dark void of space. This is the initial nuclear fission or fusion reaction, the same as on Earth. The core of the bomb undergoes a rapid chain reaction, releasing an immense amount of energy in a fraction of a second. But here's where things get interesting. Unlike on Earth, where the explosion's effects are somewhat contained and directed by the atmosphere, space offers no such resistance. On Earth, the atmosphere acts as a medium for the explosion. It compresses and channels the energy, creating the devastating blast wave and the iconic mushroom cloud that rises high into the sky. It creates the blast wave and the iconic mushroom cloud. The air absorbs and then radiates the energy, causing widespread destruction over a large area. But in space, there's no air, no atmosphere to push against. The vacuum of space means there's nothing to contain or direct the energy. The energy from the bomb simply expands outwards in a sphere of superheated plasma. This plasma radiates out in all directions, creating a perfectly symmetrical explosion. It's a silent yet spectacular show of raw energy. Without an atmosphere to carry sound, the explosion is eerily quiet. But visually, it's a breathtaking display of power and light, a true unfolding inferno in the vast emptiness of space. This difference in environment leads to some fascinating contrasts. On Earth, the destructive power of a nuclear explosion is largely due to the blast wave and thermal radiation. Think shock waves and intense heat. In space, these effects are minimized. The energy spreads out, becoming less concentrated as it travels. So, a space-based detonation wouldn't vaporize planets or cause widespread destruction like in the movies. That's not to say it's harmless, though. The real danger lies elsewhere. Section 4. The fallout on our tech. While a space nuke wouldn't directly threaten life on Earth, it could wreak havoc on our technology. Satellites, our eyes and ears in orbit, are incredibly vulnerable to nuclear explosions. The intense radiation and electromagnetic pulse, or EMP, from a detonation could fry their sensitive electronics, rendering them useless. Imagine a world suddenly without GPS, communication satellites, or weather forecasting. Our interconnected world relies heavily on these orbiting systems, and their loss would be felt globally. Section 5. The invisible chaos of EMPs. Now, about that EMP, it's a short burst of electromagnetic energy, like a powerful surge of electricity generated by the nuclear explosion. This burst can be incredibly powerful, sending shock waves of energy that can travel vast distances. On Earth, it can disrupt power grids and electronics for miles around. Imagine entire cities plunged into darkness, with no power to run hospitals, businesses, or homes. The chaos that would ensue is almost unimaginable. In space, EMP becomes even more insidious. Without the atmosphere to absorb it, the pulse can travel much farther, potentially affecting multiple satellites at once. These satellites are crucial for communication, navigation, and even weather forecasting. Imagine a global blackout of communication and navigation systems. Airplanes could lose their way, ships could drift off course, and everyday communication could come to a standstill. It's a chilling thought, and a stark reminder of our reliance on vulnerable technology. From our smartphones to our power grids, everything we depend on could be rendered useless in an instant. The invisible chaos of EMPs is a threat we must take seriously. Section 6. Echoes of Starfish Prime. We don't have to rely on imagination alone. The events of the past provide a vivid illustration of the potential consequences of high-altitude nuclear detonations. Back in 1962, the United States conducted a high-altitude nuclear test called Starfish Prime. This test was part of a series of experiments to understand the effects of nuclear explosions in the upper atmosphere. The explosion, while not technically in space, was high enough to demonstrate the potential consequences. The detonation created a massive burst of energy that illuminated the sky and sent shockwaves through the atmosphere. The EMP from Starfish Prime caused electrical damage in Hawaii over 800 miles away. This electromagnetic pulse disrupted the electrical grid, causing widespread power outages and affecting communication systems. Streetlights went out, radios malfunctioned, and alarm systems were triggered. The sudden loss of power and communication highlighted the vulnerability of modern infrastructure to such high-altitude detonations. It was a stark warning about the far-reaching effects of these weapons. The impact was not just immediate but had long-term implications for the development of military and civilian technologies. The experience underscored the need for international treaties banning nuclear testing in space, a testament to the potential chaos these weapons can unleash. The lessons learned from Starfish Prime played a crucial role in shaping global policies and agreements aimed at preventing such catastrophic events in the future.